recording. Okay, so last time where we were was let's see. So we are trying to solve. Okay, so I guess I have to zoom out a little bit. Maybe that's better. Okay, so you are trying to solve the work rate equation, and remember this is the word problems. Okay, so basically the two formulas that we use is one, when a person needs t hours, for example, to get a job done, then the rate of work is 1 over t. Okay, and remember this is the alone part. Okay, but for the together part, we find the amount of work, and that is given by the rate of work 1 over t times the together time, which will be given or be deduced from a problem. Okay, so we did this raking leaves problem. Okay, so basically here the unknown, or the thing we are trying to find, was the so-called together time. Okay, and then from here we first do the alone part, and then which means we have to find the rates, and then for the together part we just multiply the rates by x, which is the together time, which is unknown, and then we have to add them up and set them equal to 1, and then we just solve it. Okay, and remember we could end up with a fraction. Now that was a quick recap. And now number 3. So number 3 has two parts, A and B. So part A. So Henry has a big pool in his house which has two inlet pipes. One pipe, say A, can add water into the pool twice as fast as the other pipe, B. And when both pipes are left open, they can fill the pool in 26 hours. How long will it take for pipe B alone to fill the pool? Okay, so now if you compare this problem with the previous one, the raking leaves, it's similar, right? I mean, like right now it's adding water compared to raking leaves. So even though they are similar, do you notice the key difference? Okay, so for raking leaves, the x was the together time, right? Okay, now here, are we trying to find the together time, or do we already know it? We already know it. Do you see why? Now, what is the together time? That, right? Okay, because it says together they can fill the pool in 26 hours, right? Okay, so this is the together time. Okay, so here we do know the together time, but what are we trying to find? That, right? Okay, that's the unknown. Okay, so we have to set that equal to x. So let me summarize this x to be B alone time. I guess it makes sense, right? Okay, because it says how long will it take for pipe B alone to fill the pool. So x is B alone time. Okay, so now even though x is different compared to the previous one, the scheme remains the same. Okay, so what does that mean? We first do the alone part and then the together part. Okay, so alone part, and remember for the alone part we do the rates, right? Okay, so the rate of B. Okay, so the rate of work by pipe B. Now, can you find the expression for the rate of pipe B when it's left alone, or it's, opened alone, basically? So remember the formula for the rate is what? So if we know the t, which is the time, its rate is 1 over t, right? Okay, so what would be the rate of B? And to know that, what do we have to know? The time that B needs, right? How much is the time that B needs to fill the pool?
A times 2.
Well, there's no, okay, so like, yeah, like we'll get there like in a minute, but we want to find the rate of B right now, okay? And again, to know that, we have to know the time that B needs to fill the pool.
We don't know the time that B needs. We know the time that it takes B and A together.
Yeah, so we don't know the previous time, so what did we set it as?
1.
1? Well, there's no 1, but I mean, like, there's really the answer, like, right in the problem.
So 26?
26 is the together time, remember?
Right.
But the time that B takes to fill the pool. And you said we don't know, and it is right, but what's this equal to specifically?
X.
X, yes, right? Okay. So what does that mean? The rate is what? 1 over X, right? Okay. So now, what is the rate of pipe A when it is left alone? And do we have enough information to find the rate of pipe A? So what does the problem say? Pipe A can add water twice as fast as B, right? So what does that mean?
1 over X times 2?
1 over X times 2, yes. And what's that equal to? So simplify this, basically.
2 over X.
2 over X, right? Yes. Okay. Okay, so 2 over X. Okay, so now go to the together part. And remember, for the together part, we are finding the amount, right? Okay. And remember, that is obtained by multiplying the rate by the together time. Okay. So the amount of work by B. Okay, so amount of work by B. So what does that mean? We have to multiply the rate, which is what? 1 over X, by the together time. Now, what is the together time here?
26.
26. Okay, so 1 over X times 26, so that's what? 26 over X, right? Okay, now similarly, the amount of work by A, so what does that mean? We have to take its rate, which is 2 over X, and then multiply by the together time 26. So what is that, 52 over X? Okay, so now, once we get these two things, what did we do on that previous problem? We add them and set it equal to 1, right? Yeah, okay. So what does that mean? For these two, we add and set them equal to 1. Okay, so what do you notice here? It's different, okay? It's different because what we are trying to find is different, but still the scheme remains the same, okay? So now, that's the equation. How do you simplify or solve this?
Add the 2 top numbers and then multiply
Multiply by what?
by whatever the 78.
Okay. So here, do you see the way to simplify the left-hand side? So they both have the same denominator, right? So what does that mean? In that case, you can just add the tops, right? Yeah, okay. So it's 78 over x is equal to 1. Okay, so now what does that mean? To remove this fraction, what do we do? Multiply each side by LCD, which is x, right?
X.
Yeah, okay. So x is canceled here. So you just have what? 78 is equal to x, right? Okay, so what does that mean? The answer is 78 hours. Okay, so what does that mean? That's a little over 3 days. And even though I don't have a pool in my house, I was told in the past that that's a little bit of long time to fill the pool with just one pipe. Okay, so yeah, whatever. Okay, so now that is A. And then B. B is on the next page. Can I go to the next page? Okay, so now. Okay, part B. Suppose Henry replaced one of the inlet pipes, so remember there were 2 inlet pipes, with an outlet pipe, okay? Now, this inlet pipe can fill the pool in 5 hours, and the outlet pipe can empty the pool in 8 hours. Now, both pipes are left open. How long will it take to fill the pool? Okay, now, typically people ask, whenever they see this problem, why does it make sense? Okay, so here he is adding water and also at the same time he's taking the water out. How can the pool be filled? Is this a legitimate problem? And the answer is yes, it is. Even though it doesn't look like it's, you know, a reasonable problem. Why is this legitimate? Because the inlet pipe can fill the pool in 5 hours, but it empties it, like another pipe, I mean, in 8 hours, which is what? The longer time, right? So what does that mean? The speed of emptying it is a lot slower than the speed of adding water. So at some point, even if it's like really momentarily, okay, even if it's really brief, at some point in the future, the pool will be filled, right? Completely, okay? And then the water level like might decrease a little bit eventually, but at some point in the future, the water level will be filled, okay? So the problem is indeed reasonable. Do you see that? Okay, so now this problem is similar with this part A or this raking leaves. It's similar to which problem? Raking leaves or this 2 inlet pipes?
Well, we want to know the time that it takes together, so I'm going to go with number 1, although
Number
it's not
1,
really.
yes, right, yeah, this one, right? Because what we are trying to find is what?
X is the time together.
Right, the together time, right? Yes, okay. So it's similar with the raking leaves, okay? So what do? We'll just do the same, okay? So for the alone, we find the rates. For the together, we multiply the rate times the together time, and then we go from there, okay? So same thing, same thing. So for the alone part, we first find the rate, okay? So now here, for simplicity, let me label the inlet pipe as A and the outlet pipe as B, okay? So now, rate of A, the inlet pipe, is what? 1 over 5, do you see that? Okay, 1 over the time, right? And then the rate of the outlet pipe, B, is what? 1 over 8, right? Okay,
It's
and now, And now the together time, okay, so for the amount of A, so that means what? 1 over 5 times X, right? Okay, and then for pipe B, the amount is 1 over 8 times X, right? Okay, same thing as before. And now, what do we do? So from the previous or two problems before, we add them and set it equal to 1, right? Okay, so here we add them and set them equal to 1, right?
No, we subtract.
We subtract, yes. Why?
Because one of them is emptying. It's doing the opposite work.
Does everyone see that? Okay, so here we do not add, rather we subtract, yes. Okay, now, does that mean we are not adding? Well, we do, okay, because remember, this is same thing as 1 over 5x plus negative 1 over 8x, right? Okay, so here we are still adding them, okay? We are still adding them, but what does that negative sign mean? Taking the order out, okay? So maybe you have heard the expression called the net total. Does it sound familiar? The net, okay? That's not the fishing net, right? That's more like what? Like the average thing? Like the grand sum, okay? So to find the net total, we sometimes may have to put the subtraction sign, but that's actually is what the negative sign, right? Even though we are adding, okay? We put the negative sign to indicate that something is going in the opposite direction. Okay, so here, which means like what? Taking the water out, right? Okay, so that's why we use the subtraction sign here. Okay, so be careful with that. Now, here, let's see. Remove the denominator. So LCD is what?
40.
Yeah, 40, right? Okay, so multiply 40 to each thing. So 40 times 1 over 5x minus 40 times 1 over 8x, and then is equal to 40 times 1. Okay, so that means what? Simplify into 8. That becomes 5, right? So what is this? 8x minus 5x is 40. So 3x is equal to 40. Divide by 3. And 40 over 3 can't be reduced, right? So 40 over 3 hours. Okay, so what does that mean? When you divide 40 by 3, you get what? A little over 13 hours. Okay, so that kind of makes sense. Okay, so compared to the raking leaves where two guys are working together, we expect it to take a lot less time than each individual time. But what about here? We need way more than each individual time. Why? Because one pipe is emptying the water or emptying the pool, right? Okay, so that kind of makes sense. Okay, so any questions over these work rate equations? Okay, so if anyone asks like which type of problem is more important, I would say the raking leaves. Okay, because this one is kind of tricky because it involves the subtraction sign, and also the one before was also odd because x was in the denominator of our equation. Okay, so the standard form was the raking leaves, the very first one that we did. Okay, so now, so remember we'll be seeing 6 types of equations in this section. We are about a third way. So equation number 3, radical equations. Okay, now here the word radical has nothing to do with politics. Okay, so yeah, radical is not something like revolution type thing. Okay, like there's like French Revolution, and then there, like there's like people with radical left or like radical right or something. But no, there's no politics here. In math, the word radical means the root. Okay, the root. Okay, so radical means the root. So now there are two, I guess, the most popular roots, and among those two, one of them is like really famous, and that is this one, the square root, right? Okay, but we may see other roots as well. Now, just like the rational equation case where we saw, let's see, right here. So any fraction, so remember that's what rational means, right? So any fraction can go illegal when the bottom is equal to 0. Now, just like that, any square root can go illegal in the real number sense. How? Okay, so in other words, within the real number world, how can a square root can go wrong?
Zero?
Square root of 0 is okay because it's equal to
Negative.
0. Negative, yes. Okay, right? Because square root of -3, okay, for example. Now,
Is I.
right, yes. So we know what to do at this point because that is square root of +3i, but that's not a real number, right? Okay, so within a real number sense, we cannot have a negative number under the square root. Okay, so 0 is fine, but it can't be negative, right? So it has to be positive or 0. Okay, now what is the scheme of solving these radical equations? So just like the rational equation case, we have this special case. Okay, so that's the special case. So now, when you have radical equals radical with the same kinds, so what does that mean? So for example, square root equals the square root, okay? Or also you have seen this kind of root, right? What does that mean? The cube root, right? Okay, and so on. So now, for example, let's say you had cube root of, I don't know, 2x minus 1 is equal to cube root of 5x plus 3. Okay, for example. Now, before I tell you what to do, what would you do here?
I would do the math under the cube first.
Okay, so what do you mean by that?
Well, so it'd be 2x plus 5x and 3 minus 1.
3. Okay, so 2. Okay, now maybe.
And then the cubed root of that.
Now, do you mean like split the?
Oh, it's equals. I'm sorry. Never mind.
Yeah.
I thought
So
it was one plus the other. Never mind.
No, this is the equal sign, yeah.
Yep.
Yeah, so what would you do?
Wouldn't they just cancel?
Yes, so do that, right? Okay, so when you have radical equals radical and there's nothing present on the back or in the front, and these two radical, the roots are in the same kinds, you just cancel them, yes, okay? So in other words, set stuff inside the root equal to each other. Okay, in other words, cancel them out, basically, to knock out both radicals, okay? So from here, what we do is 2x minus 1 is equal to 5x plus 3. And then we go from there. Okay, so same thing. Whenever we have the roots with the same kinds, we can just like cancel them. Yes. Okay, now, otherwise, so that was the special case. Otherwise, completely isolate the root by itself on one side. Now here, I wrote the square root, but remember, we may see other roots. Okay, so in general, what I mean by that is isolate whatever root that you have by itself on one side. Okay, so you may see like cube roots or like other roots, but no matter what you have to completely isolate that. Now, for the square root, how do you remove the square root? You have to square it, right? Okay, but you have to square both sides. Okay, now, if you have the cube root, you know what to do. You have to cube it, right? To remove the cube root. Okay, so you may have to adjust this stem number 2 accordingly based on some types of problems. But for the square root, you have to square both sides and then simplify and solve. Okay, now, just like the rational equation case where we had to find the so-called bad values, and then we have to check our answers at the end, you have to do the same thing for the radical equation as well. Now, here, you are not finding the bad values though, rather you are plugging in the values into the original x. So, plug each value from the previous step into the original x, and then throw away the values that give one of the followings. Number 1, negative number under the square root. Okay, and hopefully you can see why we have to throw such values away, because that's not a real number, right? Okay, now, even if you don't see any negative number under the square root, if you see a false statement, in your equation, you have to throw such values away as well. Okay, so what does that mean? For example, like that. Okay, so as soon as you come across something like this, you have to also throw such values away, because that's just false. Like, so basically those are bad values, but here I don't want to use that term because we have used it for the rational equation case. Okay, so now let's look at the following problems. Solve cube root of 4x plus 3 is equal to cube root of 2x minus 1. Okay, so now, what do we do here? Do we have the special case?
Yes.
Yes. Do you see that? Because we have two roots, but they're the same kind, right? Okay, so here, what do? We can just like cancel the cube root sign, right? Okay, and we have what? 4x plus 3 is equal to 2x minus 1, right? Okay, so what do? Now maybe move 2x and then subtract 3. So what does that mean? These two are gone. So what do you have? 2x is equal to what? Negative 4. So x is equal to negative 2, right? Okay, so now let's check. Okay, so what do? Plug in the values into the original x and then We check, right? So check. So what do we get? Cube root of 4 times negative 2 plus 3 is equal to cube root of 2 times negative 2 minus 1. Okay? So what do we have? Cube root of, that's negative 8 plus 3, so that is what? Negative 5, right? And then is equal to cube root of, that's negative 4 minus 1, so that's also negative 5, right? Okay, now we got a negative number under the root. So do we cross out negative 2? Because that's not a real number. Am I correct? Is this not a real number, or is this a fine real number? So let's look at a few examples. Cube root of 8, what's that equal to?
Two.
2, okay. Now, what is cube root of negative 8? So what does that mean? Like, what needs to be cubed to get negative 8, right? So what is cube root of negative 8?
Two.
Cube root
I mean,
of 8 is
negative
2.
two.
Yeah, negative 2, right? Yes. And now what is cube root of 0?
0.
0. So now what do you notice? Can you have positive number under the cube root? Yeah. Can you have a 0 under the cube root? Yeah. Can you have negative number under the cube root? And the answer is also yes. So what does that mean? Under the
This is an
cube
okay
root,
answer.
so under the cube root, anything is fine. Positive, 0, or even negative. So what does that mean? Is that a legitimate number? And the answer is yes. Okay. Now, they are not what? Whole number, right? They're not a whole number. So it will be a decimal, right? But still, it is a legitimate number. Okay. So what does that mean? This is okay. Okay. So remember, we cannot have negative number under what? Square root. Okay. For the cube root, anything is fine. Okay, be careful. Now, can I go to the next page? Yeah, okay. So now part B. Okay, now look at this. Fourth root of 3x plus 1 is equal to 1. Okay, so people easily freak out. Oh my gosh, like I don't like fourth root, like already cube root is too much. Well, yeah, but this is not too bad. So now go back to the previous page here. So we don't have this special case because we just have one radical sign, the fourth root. So what do we have to check? Complete isolation of the root, right? Okay, now do we have the complete isolation of the root, the fourth root? Yeah, right? Now, how do you remove this fourth root though?
Put each side to the fourth power.
Right, raise it to the power 4, right? Yes, okay. So what do? We raise each side by power 4 like this. Okay, now in that case, what happens? We just have 3x plus 1, right? And now, what is 1 to the power 4?
1.
1. Do you see why? Okay, it's 1 times 1 times 1 times 1, right? Okay, so it's equal to 1, yes. So 3x plus 1 is equal to 1. So 3x is equal to what? 0, right? And so you divide by 3. Now, what is 0 over 3? You have 3 choices. 3, 0, undefined. Which one is it?
0.
0, yes. Okay, so now, is that the answer? Well, we don't know, so we have to check. So, plug 0 back into this original x. So what do we get? 4th root of. That's 0 plus 1, so it's just 1 is equal to 1, right? So now, is 4th root of 1 equal to 1? Yeah, right? So, looks good. So that's the answer. Okay, so A and B were fairly straightforward. Now, the main problems of this radical equation are the next two, C and D. Okay, so those are the key problems. So now, part C, x minus square root of 4x plus 12. What do we do first?
Move the x to the other side.
Do you see why? Okay, because we have to isolate the square root, right? Yes. So, subtract x. Okay, so now what do you have? Negative square root of 4x plus 12 is equal to negative x, right? Now, do we have the isolation of the square root? Not quite, right?
Can we
Because
cross
of-
out the negatives?
Right? Because of the negative sign in front. Okay, so what do we do? Divide by -1 or multiply by -1, either way. Okay, so what do we do? No matter what you do, you get square root of 4x plus 12 is equal to positive x, right? Okay, so now, how do you remove the square root on the left?
Times square it.
Yeah, well, unsquare root, which means what? Square it, right? Yes.
Square it.
Yes, square it, okay. So, square both. So, what does that mean? 4x plus 12 is equal to x squared, right? And now, have we seen this type of equation before? Yes, that's the quadratic equation, right? Now, how do you solve this quadratic equation?
Move everything to one side.
Okay, so now we can move 4x plus 12 to the right or x squared to the left. Which approach is better?
Move everything to the right.
Move everything to the right, yes. Why? Because we want to maintain this positive coefficient, which is 1, right? Yes, so subtract 4x and subtract 12 from here. So what do we get? 0 is equal to x squared minus 4x minus 12, right? Okay, and now, can you do something for this equation?
Factor it.
Factor, yes. Now, can you factor? If so, what times what?
-6 and +2.
Okay, so x minus 6, x plus 2. Okay, so x is equal to 6 and negative 2, right? Now, are we done?
No, we have to check.
We have to check, yes, right? Okay, so check. So what does that mean? Plug each one into the original x. So start from 6. So what do you get? 6 minus square root of 4 times 6 plus 12 equal to 0. Okay, so now we have to simplify this. So it's 6 minus square root of. That's 24 plus 12. So that's what? 36, right? Equal to 0. Now, is 6 minus square root of 36 equal to 0? Is that a true statement?
Yes.
Yes. Do you see why? That's equal to 6, right? And 6 minus 6 is equal to 0. Okay, looks good. And now, negative 2. Okay, and now negative 2. So we have negative 2 minus square root of 4 times negative 2 plus 12 equal to 0. Okay, so now what is this? Negative 2 minus square root of, that's negative 8 plus 12, so that is what? Just 4, right? Is equal to 0. Okay, now here we once again don't see any negative number under the square root, but is this a true statement? No. Do you see why? That's positive 2, right? And so we have negative 2 minus 2 is equal to 0, and that's false, right? Okay, so that's false. So what does that mean? Negative 2 is out. So what's the answer? Just 6. Okay, so that's why you must check, because there will be, or there could be, a number that produces, you know, the false statement. Okay. Now, one assumption that people make is, oh, okay, so negative number is always out and positive number always works. And, well, is that a safe assumption or it's a really dangerous assumption? I don't know, you'll see. Now, the next problem, square root of 6x plus 7, and then minus 9 in the back is x minus 7. Now, here, what do we do? First, yeah, plus 9, right? Yes, isolate the square root. Okay, so we have square root of 6x plus 7. And when you add 9, what do you get? X plus 2, right? Okay, and now we can remove the square root, which means what? Square both, right? Okay, so you square both like that. So the left-hand side is easy, 6x plus 7, right? Now, is the right-hand side equal to x plus 4? It looks like it's x plus 4, doesn't it? No. Why? What are you squaring? Not just 2, right? But you're squaring what? That, right? Okay. So it's x plus 2 quantity squared. And what do we have to do? Is it x squared plus 4?
Foil.
Foil, yes. Okay, it's not that, right? Be careful. So you have to foil it. So what do you get? X squared plus 2x plus 2x, which becomes what? Plus 4x, right? And then plus 4, right? And now, what is next?
Move everything over to the right.
Okay, so minus 6x and then minus 7. So x squared, so minus 6x minus 7 here as well. So that means minus 2x minus 3 equal to 0, right? Now, can we factor the left-hand side? Okay.
Yes.
Yeah. So what times what?
-2 and -1.
-2 and -1. The product is not -3.
3 and positive.
Sorry.
3 and 1.
Positive.
Okay, okay. Where's the negative sign?
Yes. -3, +1. Yeah.
-3, +1, right? Okay. So the x values are 3 and -1, right? Okay. So now that's not the end. We must check. So start with 3. So plug that into the original x right there. So it's square root of 6 times 3 plus 7. And then minus 9 in the back is equal to 3 minus 7. Okay, so now simplify. That's 25, right? 18 plus 7. Okay, and now square root of 25. What is that? 5, right? So what do you have? 5 minus 9 is equal to 3 minus 7. True or false?
True.
That's true, right? Because both sides are equal to what? -4, right? Okay, so it looks good. And now, -1. Square root of 6 times -1 plus 7, and then minus 9 in the back. -1 minus 7. Okay, now, that's -6. So plus 7, so that's just +1, right? Okay, and now square root of 1. So what is that? That's just 1, right? So we have 1 minus 9 is equal to -1 minus 7. True or false?
True.
That's also a true statement, right? Because both sides are -8. So what does that mean? Both numbers survive. Okay. So even if you see a negative number, that might be the answer. Okay. And the thing is, sometimes for some square root equations, both numbers may not work. So you have to cross them out, which means the answer is no solution. Okay. So you don't know what's going to happen until you explicitly check. Okay. Any questions over these square root equations? Okay, so now, equation number 4. Equations with rational exponents. Okay, so now remember the word rational means fractional. And so far, our exponents were just whole number like this, right? But hopefully you have seen something like this. Okay, the fractional exponent. Okay, so here, what we would like to do is convert such fraction exponents into radical expression, the root, and then simplify. Okay, so we will somehow use this fact. So suppose we have a to the power m over n, and that's equal to b. Okay, and here a contains the variable. Now, to get a by itself. So how do we get a by itself? We have to remove m over n, right? How do you remove m over n? What do you have to do?
Isn't it the square root of the top number to the power of, so it would be like square root of 1 to the power of n.
Okay, so now here there's no square root, but here to remove m over n, we have to multiply by the reciprocal, right? N over m, right? Now, when can you multiply the exponents? When you are doing what? Raise every side by the reciprocal power. Remember that? Do you see that? I mean, like from here, let's see if I can come up with some simple problem. The difference between this versus this, which one is the multiplying exponent case? This one or this one? So in other words, which one is x to the power 6? And which one is x to the power 5?
The first one's to the power of 6.
Right? So that's multiply and that's add, right? Yeah, okay. So what does that mean? Here, when we multiply the two exponents, that means we are raising each side by the reciprocal power, n over m, right? Okay, so to isolate a, we do this, right? Okay, in other words, raise b to the reciprocal of m over n, right? Okay, then we'll have just a by itself, right? Now, the next step is we rewrite this b to the power n over m as something like this. Have you seen this conversion formula before? So this is the conversion that allows us to convert this rational exponent into the radical symbol. Have you seen that? So what does that mean? This bottom number goes to the outside, so that denotes the kind of root, right? And then this b to the power n goes to the inside like this. Okay, and now we can further simplify this mth root of b to the n. Does anyone know how to simplify this? What can you do with this inside power n? Can you do something on it? Can you do that? Pull it out? What does that mean? Do that, and then raise that to the power n. Does it look any familiar? Not at all? Okay, so first we raise the right-hand side by the reciprocal of the left-hand side exponent. And then we rewrite that into this radical expression. And then we pull the inside power out, and then we place them outside. And you'll see why we do this, because it reduces our work so much, okay? Now, can I go to the next page? Okay, so now, let's do these two problems. Solve x to the power 3/2 is equal to 216. Okay, so now solve means what? Get x by itself, right? So what do we do? How do you get x by itself? So in other words, how do you remove that 3/2?
Multiply by the reciprocal.
Right, so okay, so now multiply means what?
Oh, raised to the power of the reciprocal.
Right, so raise 216 by the reciprocal, which is 2/3. So what does that mean? X would be equal to 216 to the power 2/3, right? Okay, so again, this is not 216 times 2/3, right? It's 216 to the power 2/3. And now don't be excited because you are not done. You have to further simplify 216 to the power 2/3. So now, how do you further simplify 216 to the power 2/3? So can you convert this into radical expression, some kind of root?
Wouldn't it be the square root of 216 to the third power?
Oh, you have to flip it. It's not the square root.
So
You
the
see
cube
why?
root.
Yeah, because that denominator goes to the outside, right? Okay, so it's not the square root, but it's rather the cube root, right? And then we have 216 to the power 2. Okay, now from here, what some people do is multiply 216 by itself, which is kind of insane number, and then find its cube root. And the sad news is I don't even know what 216 square is. It's just some big number, okay? So now, how can we reduce our work? What do we do with that?
The square to the outside.
Okay, so now we have cube root of 216, and then it's squared, yeah? And now, can anybody see what cube root of 216 is? That might be a little bit tricky. Now, that's not a decimal, that is a whole number.
Is it 6?
That's 6, yes. 216 is a so-called perfect cube. Have you heard about that? So, in other words, you have to see what needs to be cubed to get 216, right? And so you can just try a bunch of numbers. So first of all, that's not 2, right? So it has to be bigger than 2. Okay, so you can just keep going and you will get 6 cubed is equal to 216. So we have 6 squared, which is equal to 36. Okay. So that's the beauty of this pulling the inside power out thing, because that will reduce our work by a lot. Okay. So 36 was the answer. And now, part B, x squared plus 2x, everything to the power 1/3 is equal to 2. Okay, so first thing first, remove that power 1/3. How?
Cube the 2.
Right? So we cube both sides. So cube it. Then these threes will cancel, right? Okay, so we just have x squared plus 2x is equal to 2 cubed, which is 8, right? Okay, so again, we have seen this type of equation like trillion times in the past. So first subtract 8, and then factor. Is it possible? Yeah. So what times what?
Four times 2.
Yeah, so 4 times 2. And now, where is the negative sign?
The negative's on the 4.
Negative is on the 4. And then what about that?
It's a positive.
Oh, it's a positive? Okay, so x minus 4 times x plus 2 is equal to 0. Something looks a little bit off.
It's the other way around.
Yeah, right? So that and that, right?
Oh, shit.
Yeah. Negative sign can always kill people, right? Yeah. Even though that's a minor thing, that can be big at the end. Okay. So x is equal to what? Negative 4 and positive 2, right? Okay. So those are the answers. Okay. So that is the rational exponent equations, and hopefully it was not too terrible. And now, equation type number 5. Now, the thing is, the textbook does not mention the specific name of this kind of equation, so I called it double quadratic. And here, what you'll see is the equation with x to the power 4 and x squared only. So what does that mean? There's no x cubed, there's no x. Okay, and here's an example. 4x to the power 4 minus 8x squared plus 3 is equal to 0. Okay, and as you can see, there's no x cubed or x to the first power. Okay, so now here, the scheme is step number 1. Set u to be x squared and rewrite the given equation. Okay, now, sometimes people call it u substitution, but I don't want to use this u substitution because for those who have to take calculus in the future, you come across the so-called u substitution method. Okay, and that's completely different compared to this one. But basically, we substitute the letter u instead of x squared. Now, why is this a good approach? So, if u is x squared, what is u squared? X to the what power?
U squared equals x to the 4th.
X to the 4th power. Do you see that? Yeah, because it's x squared square, right? So it's x to the power 4. Okay. Now, I claim that we can transform the given equation into a standard quadratic equation. Now, why? Because look at this following problem here. If we set u to be x squared, okay, then we claimed that u squared is x to the power 4. So what does that mean? This is 4u squared minus 8u plus 3 is equal to 0, right? Okay, so we haven't seen the equation of this type, but we do know how to solve this, right? Which is the standard quadratic equation. Okay, which means what? We can solve for u. Now, once you find the value for u, are you done? And the answer is no, because you had x as the original variable. Okay, so we put x squared back into the equation and then solve it again. Okay, so what do you notice? We are solving the quadratic equation twice, which is why I called it double quadratic equation. Now, let's look at this problem here, okay, and let's finish it. So 4u squared minus 8u plus 3 is equal to 0. Now, the usual question, can we factor this?
-6 and -2.
Okay, so -6 and -2, right? Okay, now, so I guess the difference comes in whether you want to use the AC method or that Mustang thing, right? Okay, so now, what do you want to use?
I prefer Mustang method.
Okay, so -6 and -2. So u minus 6 and u minus 2. And do you remember what the next step was? Divide 6 and 2 by what? Remember that? Okay, and again, I can't emphasize this far enough, but if you don't feel comfortable with using this Mustang method, don't ever try to use it because you may struggle. Okay, so, and now what do you do? Reduce. So it's what? U minus 3/2, and then that's 1/2, right? And so what does that mean? That and that. So you have 2u minus 3 and 2u minus 1, right? Okay, so we have equal to 0. So what does that mean? U is equal to, so by setting each factor equal to 0, U is what? 3/2 and U is 1/2, right? You got that? Okay, so now here's my next tricky question. Do we square these two fractions to get x? No. Okay, be careful. Because why? U was what? X squared, right? Okay, so now put x squared back in. So we have x squared is equal to 3/2 and x squared is equal to 1/2. And now, how do you get x by itself from each of these equations?
Square root.
Square root, yes, right? So square root. So x is equal to square root of 3/2 and x is equal to square root of 1/2, right? And now we are done, right? Right?
Plus or minus.
Say that again.
Plus or minus.
Thank you. Plus minus. Okay. Yeah. Yeah. Told you. Plus minus. Okay. Now, plus minus. Don't forget plus minus. Okay. Yeah. Plus minus. That's important, right? So now, plus minus. Square root of 3/2 and plus minus square root of 1/2. Now, if this were an exam problem on paper, I would be okay with these two numbers or expressions, but not for the MyLabs Plus. And why? Because I don't know. Like somehow NLP doesn't like it. So you have to go further. Okay. So how further? You can split this square root into square root of 3 over square root of 2. And then similarly, square root of 1 over square root of 2 like this. Okay? And now, how can you remove the square root at the bottom? Multiply by the denominator. Remember that? Okay? So, times square root of 2 at the top and bottom. So what do you get? Plus minus square root of 6 over 2. And then plus minus square root of 2 over 2. So that is the answer that MyLabs Plus want. Okay, again, it's kind of picky, so please be careful. Okay, so you have to go up to this point. So how many answers did we get? How many numbers?
4.
4, right? Yeah. Square root of 6 over 2 with its negative, square root of 2 over 2, and it's negative. So we got 4 numbers. Okay. Okay. So now the equation of the last type. Can I go to the next page? Okay. So solving for a specified variable. Okay, so we have seen this scheme before. We'll see multiple letters, and you just have to isolate the target variable, right? So let me go straight into the problem. Solve d equals k square root of h for h. And where is h? right there. Okay, so you have to isolate H. So what do we do first to get H by itself?
Subtract or divide K.
Divide by K, right? Yes, divide by K. So that means D over K is equal to square root of H. And now, how do you get H by itself from here?
Square D over K.
Right? Square both, yes. Okay, so when you square both, you get D over K, quantity squared is equal to H, right? Now, one little thing. How do you clear parentheses on the left-hand side? That's just like simple rewriting things.
D squared divided by H squared, or K squared.
Right? Yeah, so distribute 2, right? Yes. Okay, so D squared over K squared equals H. Okay, so that's the answer. And now, next, E over A is equal to R plus B over B. And isolate A. And A is right there. Okay, so how can you get A by itself?
Multiply both sides by A.
Multiply both sides by A. Now, then we will remove A from here, but there will be A on the right-hand side. So that doesn't quite help us, because all we are doing is just moving A to the right-hand side.
What if we multiply both sides by A over E?
A over E. Okay, so A over E. So that means the left-hand side will be 1, but still there will be A on the right-hand side. And we'll see another fraction. So that doesn't quite help us either. So here's my simple problem. Right, like that. What would you do?
Least common denominator.
Okay, so what is LCD? So what is LCD for this problem here?
AB.
AB, right? Yeah, okay. So LCD is AB. Okay, so we multiply this to everywhere. Multiply this to everywhere. So what does that mean? We have E over A times AB, and then R plus B over B times AB. So A's cancel and B's cancel, right? So we have what? EB is equal to R plus B, and then times A outside, right? And now, what would you do next?
Divide by R plus B.
Divide by R plus B, yes. Do you see that? Some people choose to distribute A, but you don't have to, because what's your goal? Get A by itself, right? So what do? Divide by R plus B, yes. Divide by R plus B. So you have EB over R plus B is equal to A. Okay. So we have isolated A. And now the last problem. S equals 2 pi r h plus 2 pi r cubed, and isolate h, which is right there. So first, what do we do?
Can we remove the 2 pi r from the first part and take the cubed one down to a squared?
Okay, so which 2 pi r do we move? This one or this one?
One on the left.
One on the left? Not yet.
Wouldn't you subtract 2 pi r cubed
Minus 2
first?
pi r cubed first, yes. Okay, so S minus 2 pi r cubed is equal to 2 pi r h. And then we divide by 2 pi r. So what do you get? S minus 2 pi r cubed all over 2 pi r is equal to h, right? Okay, and now, next question. Can we cancel the 2's, pi's, and simplify r cubed over r? So is the answer equal to S minus r squared equals h? No, but that is very common mistake that people make. So if you want to further simplify like this, what do you have to do? Put that.
Multiply by both sides.
No. So here, from here, you can split the fraction like this. And then simplify what? That only. Okay, and you cannot simplify this one. So either this or stop here. Okay. So you cannot just say S minus r squared is equal to h. No, you cannot do that because this S doesn't have any 2 pi r. Okay. So either stop here or split the fraction and then simplify the second fraction only, and you get something like this. Okay, that's all. Okay, so any questions over these problems? Okay, so now that's the end of 1.6, which was rather long. And now the last section of chapter 1 is 1.7. Okay, so now in 1.7, we will look at the inequalities. Okay, and there are 3 types of inequalities that we will look at: linear, quadratic, and rational. Now, no matter which type of inequality that we solve, there is the same preliminary that we have to cover. Now, hopefully you remember this from your previous math class. When you multiply or divide both sides by a negative number in the inequalities, remember, what do you have to do in terms of the sign? Do you remember?
Flip them.
Right? Sign change. Okay, flip the sign basically. And now, the second remark. Write your answers in the interval notations and then graph the solution. Okay, on the number line, I mean, not the XY plane. Now, speaking of the interval notations, has anyone heard about interval notations before? Or has anyone seen it? Okay, so now, the thing is, we cannot lecture over these interval notations in this class. So for those who have not seen this before, hopefully you get to know it as we do the problems. But the thing is, all of you are supposed to have seen this before. Now, there are 4 starting points. So these double inequalities, hopefully you have seen them at least. Now, when x lies in between a and b, but a cannot or x cannot be equal to a or b, we use parentheses a comma b parentheses. Now, we place the first less than sign by less than or equal to, then we use bracket a comma b parentheses. Now, if the less than or equal to sign is moved in between x and b, we put bracket around b, and then we put parentheses a, and then less than or equal to everywhere means bracket a comma b bracket. Okay, so what do you notice from these 4 interval notations? So those are the interval notations. And what do you notice? Number 1, we put a bracket for less than or equal to, and we put parentheses for less than inequality sign. And then number 2, from A and B, which one is greater and which one is smaller? So from the first one, it says A eventually is less than B. And then same thing for number 2, 3, and 4. So we put the smaller number first and then the greater number. Okay, not the other way. So we put smaller number, comma, bigger number. Okay, not the other way. And then we use parentheses or brackets or mixture. Okay, but we always put the smaller number first and then the greater number. Okay, and then another remark. In these 4 inequality notations, do you see greater than or equal to? No, right? It's just less than or equal to or less than. That's it, right? Okay. So greater than or equal to or greater than, these are not part of the interval notations. Now, does that mean we will not see these 2 inequalities ever? Oh, yes, we will. But they're not just part of the official definitions, basically. Okay? So you have to do something if you see those 2 inequality signs. Okay? So again, these 4 are the interval notations that you have to know. So now, there are 3 special interval notations. What's the interval notation for x being less than or equal to -3? So now, in this case, you have to ask yourself, is this inequality sign okay? In other words, is it part of the official one of the 4 definitions? And the answer is what? Yes, right? Because we will see either less than or equal to, so that's fine. So now what does that mean? Is -3 your B or A? And how do you tell? B has to be what? On the right side of x, right? And A is always on the left. Okay, so what does that mean? That is your B, right? And where do you write B? Always on the second slot, right? Okay, so it's something comma -3. And what's the symbol around -3? Bracket or parentheses? Bracket. Do you see why? Less than or equal to, right? And now, what do we write here? So basically, there's nothing on the left-hand side of x, right? So there's no A. Does that mean we don't write anything? Well, we have to write something. But what do we write?
The same number?
It has to be smaller number. Now, people tend to write 0, but what's the problem? 0 is greater than -3, right? So that's false. Okay, but we cannot write x either because there has to be a number that comes in, not any variable. Okay, so have you seen that symbol or that number? Does it look familiar? Now, what does that mean? How do you pronounce this? That's not -8, right? It's not -8. What's the
Infinity.
number equal to? Negative what?
The infinity?
Infinity. Okay, negative infinity. Now, is negative infinity small or big? Very small, right? Because like think of what -1,000,000, for example, that's very small, right? Okay, and whenever you have negative infinity, you always use parentheses. Okay, so that is the inequality or interval notation for x being less than or equal to -3. Now, special interval notation number 2, x is greater than 2. Okay, so here we go. So now you have to ask yourself, is this the right inequality, the greater than? And the answer is no, it's not part of these 4 definitions, right? So what do you have to do? You have to flip it, okay, which means 2 less than x. And if you get used to this, you don't have to flip it like this, but if you haven't seen this interval notation before, that's what you have to do. And now, ask yourself, is 2 your A or B? It's A. Why? Because A comes before x and 2 comes before x as well, right? Okay, so 2 is your A, but what is your B? It's not there, right? Okay, it's not there. So what does that mean? It's 2 comma something. And now what's the symbol around 2? Parentheses. Because we don't have equal to part, right? So it's parentheses 2, comma, and then what do we write? Again, we cannot write 0 because we have to have some kind of bigger number than 2.
Infinity.
Infinity, yes. Okay, so that's infinity. And is infinity big or small? That's very big, right? Like think of million, for example. And just like negative infinity case, whenever you write infinity, you always use parentheses. You don't ever use bracket. Okay, so that is the interval notation. And now the last special interval notation for all real numbers. Can you guess what all real number means for the interval notation? We have covered all the basics.
Negative infinity.
Parentheses with negative infinity, comma to infinity with parentheses.
Right, so the smallest possible number, which is negative infinity, and then the largest possible number, infinity, and then parentheses everywhere, yes. So that is all real numbers. Okay, so those are the basics of interval notations, which I cannot lecture in any greater details. So if you are confused by these interval notations, you must ask, okay, later. Now, let's look at the first inequality type. So linear inequality, single and double. Now here, your common goal is to isolate x. And when you have a single inequality, do the algebra until you isolate x. Okay, so for example, something like this. Okay, like such as divide by -2, for example. Now, for the double inequality, x appears in the middle. So for example, something like this. Okay, and you want to isolate x in the middle. So what does that mean? For example, here you would add 3 and then divide by 2 to isolate x. So whatever you do in the middle to isolate x, what do you have to do? Do it to everywhere. Okay, so what does that mean? Add 3 to every side, okay, and then divide by 2 every side as well. Okay, so whatever you do in the middle to isolate x, you have to apply it to all sides, not just in the middle. Okay, so now these are fairly easy, so let's just do only 2 problems, which is on the next page. Okay, so solve each. Express your answer in interval notations and graph the solution. And remember, graph the solution means what? Graph on the number line, right? Okay, not xy plane. So negative 2x plus 7 is less than negative 5. Okay, so now here there are only 2 steps. Step number 1, what do we do?
Subtract 7.
And then,
Divide by -2.
okay, so now when you subtract 7, you get negative 2x and negative 12, right? Do you change the sign?
No.
No, okay, so it's still less than. And then divide by -2. So when you divide by -2, you get x and then positive 6 on the right. Do you change the sign?
Yes.
Yes, okay, so it's x is greater than 6. And now, interval notation. So what's the interval notation of x being greater than 6?
You have to flip
6,
it.
comma, infinity with parentheses around.
Okay, okay, so now, is this, so do we write 6 in the second slot or first slot? So it's something, comma, something, right? Do we write 6 here or here?
It's 6 comma infinity.
It's 6
Right.
comma infinity, right? Do you see that? Because it's 6 being less than x, right? If you want to rewrite once more. So it's 6 comma something, but there's nothing in the second slot, so it's 6 comma infinity, right? And what are the symbols?
Parentheses.
Everywhere, right? Yes. Okay, so 6 comma infinity, parentheses everywhere. And now, how does the graph look like? So remember, graph means on the number line. So here is 6 on the number line. And now, where do we shade? So there are 2 regions, left and right. Where do we shade?
The right.
The right side, right? Because x is greater than 6. Okay, so we shade the right-hand side region. And maybe you have seen that symbol before, that empty circle. What does that mean? That's exclusive, right? Exclusive endpoint. Okay, so the endpoint 6 is not included, right? But if it is included, then you put this closed circle. Remember that? Okay, so it's just that. Now, -5 less than or equal to 4x minus 5 all over 2 less than 1. Okay, so now x is in the middle this time. What do we do? First, to isolate x.
Multiply both everything by 2.
Okay, so multiply everything by 2. So times 2 times 2 times 2. So these two 2's cancel. And we have -10, and then 4x minus 5, and then 2. Do we change the signs or do we keep them? We keep them, right? So less than or equal to and less than. And now, what do we do next?
I'm sorry, can you explain one more time why you keep or change the sign?
You change the sign only when you multiply or divide by a negative number. Okay? So
Great, thank you.
here, even though we are multiplying everything by 2, that number 2 is positive, so that's why we don't change the sign. Okay, did I answer your question?
Yes, sir, thank you.
Okay, so now what do we do next? Plus 5, right? So plus 5 to everything. So plus 5, plus 5, plus 5. So what do you get? -5, and then 4x and 7. Change the signs? No, right? So still less than or equal to and less than. And now divide by 4 is next. So divide by 4. So it's -5 over 4, and then x and 7 over 4. Change the signs? Still no, right? Yeah, because 4 is positive. Okay, so now x is isolated, so that's it. And now, what's the interval notation? So now, from here, are we going to see infinity or negative infinity as part of the interval notation? No. Do you see why? Do we have something on the left side of x? Yes, we do. Do we have something on the right side of x? Yes, we do. So what does that mean? -5 over 4, comma 7/4. And what are the symbols?
Bracket on the left, parentheses on the right.
Right? And now, how does the graph look like? So now on the number line this time, we have two significant numbers. Do you notice that? What are the significant numbers? -5/4 and 7/4. And now here we have three regions, left, middle, and right. Where do we shade?
Shade in the middle.
Shade in the middle, yes. And now, what happens at the two ends? What kind of dots should we put?
The left side dot needs to be filled in. The right side needs to be
Open, right? Yes. Okay. So, filled in circle versus empty circle. Okay. So, that is the graph. Okay. So, any questions over this single or linear inequality case? Okay, so hopefully it's not too bad. Now, here comes the bad part, or a bad part, I should say. The second bad part is coming. The quadratic inequality. Okay, and now unfortunately, there are lots and lots and lots and lots of steps. But although this scheme may look terrible, once we actually do the problems, it's not going to be that bad. And you'll see why. So, quadratic inequality. So the thing is, we have seen quadratic equation before that looks something like this. So what does quadratic inequality mean? Something like this. Okay. So now, what do we first do? let's pretend that we have something that's familiar already. That is what? Equation. Okay, so pretend that we had an equal sign and solve the resulting quadratic equation. Okay, then what do you get? Just two numbers, right? Now, what you do is divide the number line into regions whose boundaries or the wall values are those from the previous step. Now, at this point, that regions may look unclear, but once you actually do the problems, you'll know why I call them regions, okay? Now, from each region, you choose a small whole number, which serves as the representative from each region, and plug that into the inequality. Okay, and now here, choose the number 0. Okay, so the thing is, one of the regions will contain 0. Okay, and plug 0 into the original inequality. And you'll see one of these two statements. True statement. If you get a true statement, you keep the region. However, if you get a false statement, you throw that region away. Okay, and now here's my another tip. You will see either that or this. Okay, now it's that OXO or XOX. Okay, it's not XOXO, for example. That means something else, right? Like XOXO. Anyways, so it's not XOXO. Okay, like it's OXO or XOX. Okay, and you'll see why. Like there's a good reason that why I call it this way. Okay, and now for the survived regions, write your answer in the interval notation, and a few things to keep in mind. To come up with the intervals, do not use the representatives from here. Okay, those are representative, and if you have used it once, it's gone. Okay, so use the wall values instead. And as always, if you see less than or greater than, put parentheses. Less than or equal to or greater than or equal to, put brackets. Okay. Now, I know this scheme looked awful, and it is, but the thing is, I gave you plenty of hints and shortcuts, so you'll see that it's not that bad once you actually do the problems. So now, let's do the problems and illustrate these schemes. Okay, so solve each and write your answer in interval notations. Okay, so let's look at this following problem. Okay, x times x minus 2, can you see it from the bottom of the screen, is less than or equal to 15. Okay, so now what is step number 1? Remember, pretend that we had an equal sign and solve the equation. Okay, so let's see. Step number 1, x times x minus 2 is equal to 15. And now, do we know how to solve it? Now, what do we do? There are two things that we have to do. What are they?
Distribute x and move the 15 to the left side.
Right? So x squared minus 2x minus 15 is equal to 0, right? And now, can we factor the left-hand side? Yeah, right? So what do you get? What times what?
Three and 5.
Okay, and now where's the negative sign?
The 5.
Right? So x is equal to negative 3 and 5, right? Okay, and now remember, those two values, as the step 2 says, become the wall values. Remember that? Okay, so these are the walls. Okay, so what does that mean? Step number 2, divide the number line into regions, okay, whose boundary values are negative 3 and 5, right? So what does that mean? Here is the number line of x values. And there are two wall values, negative 3 and 5, right? So the left wall will be negative 3 and the right wall will be 5. And now here, do you see the regions? Now, how many regions do you see? Don't say 6. It's not 6. This is one-dimensional, right? So how many regions do we have? 1, 2, and 3. Okay, left, middle, and right. Okay, so now what does each region represent? So the left region is what? X is less than negative 3. And then the middle region is what? In between, right? Negative 3 and 5. And then what about this right region? Anything greater than 5, right? I'm just labeling each region. Okay. And now here for this problem, I will put less than or equal to and greater than or equal to everywhere. Now, do you see why? Because at the beginning, what kind of inequality did we have? Less than and equal to, right? So we just put this extra bar to be consistent with the sign, okay? So now that's step number 2. And now what is step number 3? Choose a small whole number, but in particular, I gave you this big hint. Choose a 0. Okay, now, does one region contain 0? And if so, where is 0? Left, middle, or right?
The middle.
The middle. Here is 0, right? And now, what do you have to do? Plug that into the original inequality. So what does that mean? Right here. Okay, so what do you get? 0 times negative 2, and that's just 0, right? So what do you get? 0 less than or equal to 15. Now, is this a true statement or a false statement? 0 less than or equal to 15.
True.
That's a true statement, right? Okay, so whenever you get a true statement, what do? You keep the region. So you keep this. Okay, so now go back to my previous tip right there. OXO or XOX. Now, even though we are not choosing any values from the left and right regions, what do you expect to happen for the left and right regions? Keep them or throw them away?
You're going to have to throw them away.
Throw them away, yes. So it's just big X right there. Okay, so like for example, you can choose like for example, negative 4 and 6, and you can plug those two values into here, but you will not get a true statement basically. And you can verify this fairly easily, okay? But I'm reducing your work, okay? So that's why I mentioned these two tips, okay? So what is the survived region? The survived region is what? The middle one, right? Okay, and what does the middle region represent? The label of the middle region was what? -3 less than or equal to x less than or equal to 5, right? That was the name of the middle region. And now, what is its interval notation? So here, we will not see any infinity or negative infinity, right? So what does that mean? It's -3, 5. And what are the symbols?
Brackets.
Brackets. That's the answer. Okay. See, it's really simple, right? It's not that bad. I mean, the scheme, like the word itself looked terrible, but what do you notice? Like it's not that long. Okay, so yeah. And now part B. -x² minus 6x minus 16 less than or equal to -8. Okay, so again, what do we do? Oh, do the same thing. Equal sign, solve it, and get wall values, divide the number line, plug in 0, and so on. Okay, so number 1, -x² minus 6x minus 16 is equal to -8. And now, how do you solve this quadratic equation?
Multiply by -1.
Okay, so multiply by -1, and then, so we get positive x² plus 6x plus 16 is +8. Okay, and then,
Subtract the 8.
okay, subtract 8. So x² plus 6x plus 8 is equal to 0. And now, can you factor the left-hand side?
X plus 4, x plus 2.
Okay, so x plus 4, x plus 2 is equal to 0. So x is equal to -4 and -2. Okay, and remember these two values become our boundary values. Okay, so now step number 2, divide the number line. Okay, so here is the number line of x values. So 1, 2. Okay, so the left wall is -4 and the right wall is -2. Okay, and just like before, let me label each region. So the left one is what? Less than -4. And the middle one is in between. And then the right one is greater than -2, right? Now, why did I put the equal to part here? Because that's what we had at the beginning, right? Okay, so because we had equal to part as inequality at the beginning, we just put this equal to parts here as well. And now, does any region contain 0? Where is 0?
To the right.
To the right. Here is 0, right? Yes. Okay, so plug that into the original x, and what happens? That's gone, and you have just -16, right? And then less than or equal to -8. Now, is this a true statement? Yes, right? So that's a true statement. So that means we have to keep this region, right? Now, without checking the other two regions, what's going to happen to them?
Keep the left one and get rid of the middle one.
Right? It's this one. Okay. I mean, here you can plug in like -5 and maybe -3, but still you'll get these two things. Okay, keep it and then throw it away. So now here, what are the survived regions? The survived regions are the left one and the right one, right? Okay, now what was the name or the label of the left-hand region? X is less than or equal to -4. And what was the label of the right-hand side region? Greater than or equal to -2, right? Okay, it's right there. And now, what is the interval notation in this case? So, what's the interval notation of x being less than or equal to -4? Are we going to see infinity or negative infinity in this case?
It's brackets, negative infinity, comma, negative.
Okay, so negative infinity, comma, -4. And where is the bracket?
On both.
On both? Not both. Why? Because when you have infinity or negative infinity, what's
can't
the
go below.
symbol? The parentheses, right? Okay. And now, what about here? What's the interval notation in this case?
Bracket, -2, comma, infinity, parentheses.
Right, this one. Okay. And now, in the middle of these two intervals, we have to put a symbol. And maybe some of you have seen this symbol before. Can anybody come up with an idea which symbol we need to put? We cannot put this comma. You have to put something else. Have you seen that symbol before? The U? No? What does the U represent? Union. Okay, and union means or. So what does that mean? Either this interval or that interval. Okay, but not both, basically. Now, that's the answer. And when you do your homework, for this U, do not type capital U from your keyboard. MyLabs Plus will not recognize. Instead, there is a like small symbol toolbox for the problems, and in that toolbox there will be this U symbol. Okay, so you cannot use capital U from your keyboard. Okay, in the past, one person said, well, my answer was right, but MOP says my answer was wrong. And I looked at closely, and that was the difference. Like the difference between the capital U is something like this, and then like this. That's the symbol from MOP. That's the capital U. Practically the same, but I guess it's a little bit shorter. That's all. Okay. So be careful. Okay. Okay. So now the next problem. 4x squared plus 3x plus 1 is less than 0. Okay. So now here, step number 1. Pretend that we had equal sign. 4x squared plus 3x plus 1 is equal to 0. Okay, so now factor the left-hand side. How can we factor the left-hand side? So if you think something is weird, can we even factor the left-hand side? No, we can't. Okay, so you can easily verify this. We cannot factor. So what is the only way to solve?
Quadratic equation.
Quadratic formula, right? Yes, the quadratic formula. Okay, so now hopefully you still remember your quadratic formula and maybe you have memorized it at this point. So now in quadratic formula, what do? Identify A, B, and C, right? Remember that? So A is equal to 4, B is equal to 3, and C is equal to 1. And now, what was the quadratic formula? X is equal to, what do we write first at the top?
Negative b
Negative B, so that's negative 3, and then
plus or minus square root of b squared
yeah,
minus 4ac.
minus 4 times 1, and then all over 2A. So 2 times 4, right? So now, simplify the number under the square root. What do you get? So what is this? 9 minus 16, right? And what's that? Negative 7? All over 8? And now what do you do after this?
You can take the negative sign out of the square root and make
Okay, so negative 7 or 3 plus or minus square root of 7i all over 8. And now, how many boundary values did we get? Two? 2 seems to be the obvious answer, but here, be careful. And look at this previous picture. This is where the boundary values lie. Now, on this number line, where is the I? Where is I on this number line? There isn't one, right? You see
There's
that?
no answer.
Right? So now, yeah, we got the 2 well values, but what's the problem? The number line has no I. So what does that mean? These are not the boundary values. Okay, these are not the boundary values. So what's the answer? Someone already said it.
There is no answer.
There's no answer, no solution. Yes. Haha. Okay, so there was a trap here. Okay, so if you get an I as your boundary values, then there's no solution. Okay, so there was a trap for this problem. Okay, so now, even though we went about 3 minutes over time, let's quickly do one more problem, okay? And then we will do the word problem tomorrow. So 3x squared minus 11x minus 4 is greater than 0. Okay, so now, step number 1, 3x squared minus 11x minus 4 is equal to 0. And now, this time, can we factor the left-hand side?
No.
Well, yes, we can. Yes, we can. What are the 2 numbers?
Negative 12 and 1, but you have
Negative
to
12 and 1, right? Yeah, okay. So let's see, x minus 12 and x plus 1, and then divide by 3. So now, can you see the two factors? What is one factor?
-4, which would be +4, x equals +4.
Okay, so yeah, x is equal to +4, and then what's the second factor?
One-third, which would be negative, x equals -1/3.
Okay, right, so 3x plus 1, right? Okay, and then x is equal to +4 and -1/3, yes. Okay, so now this time we got the legitimate wall values. Okay, so now divide the number line. So now the left wall is what? -1/3, and the right wall is +4, right? Okay, so now just labeling the regions. So the left one is x is less than -1/3. The right one is in between -1/3 and 4. And the right region is x is greater than 4. Now, this time, do we put the equal to part? Do we put equal to here? No. And what's the reason? At the beginning, did we have equal to sign? No. It's just greater than, right? Okay, so it's just that. And now, does any region contain 0? Where is 0?
Middle.
In the middle, right? Yes. Okay, so now plug 0 into the original x. What do you get? That's gone. That's gone. And so you just have -4 greater than 0, right? And this one is what? True or false? That's false, right? So what does that mean? The middle region is out. So what do you expect for the other two regions? Keep them, right? Okay, so now, what are the survived regions? The survived regions are the left one and the right one. And now, what was the label of the left region? X is less than -1/3. And what about the right one? X is greater than 4, right? And now, what's the interval notation of x is less than -1/3?
-infinity,
And then,
-1/3,
and now what are the symbols?
parentheses and a bracket.
Parentheses and
Oh, parentheses.
another parentheses, yeah. And what about x is greater than 4?
Parentheses 4, comma, infinity, parentheses.
Okay, and in between these two intervals,
U.
the u, right? Yes. Okay, so that is the answer. Okay, so now tomorrow we will do this word problem about this quadratic inequality. And then there is the rational inequality as well, which is a little bit trickier than this quadratic inequality, but most of the schemes remain the same. And there are only two problems, which is a good news. So we will wrap up this section tomorrow, and then we will go back to chapter 2, and then we will start section 3, okay? And remember, tomorrow is not the exam day, right? Tomorrow is just regular class day, and your exam is Wednesday, okay? So the plan for Wednesday is, if you want to take the exam during our class, which is between 10 and 12, you will be taking your exam at the beginning of the class period. So from about 10 to 11:20, And then when you're done, you'll have to wait until everyone else finishes. And then when everyone else finishes, we can just do the lecture for the remainder of the class, about 40-ish minutes. Okay? So that's the plan. And if you have any questions, just feel free to let me know, either via email or via office hour, which is right now. Okay? So that's it, and have a good afternoon. I'll see you tomorrow at 10.
Thank you. Bye.
Welcome. Bye.